Hi everybody, I think that's the time to start. So thank you very much for joining us today. My name is Pierre Friad and I've been working for PCM for quite a few years. So I will first tell you a few words about who we are. So PCM is a complex fluid handling specialist and we've been providing food processing equipment to food industry for decades. Our supply would typically include food dosing stations, mixers, pumps, or fillers. We address many different food markets around the world, and I've seen over the last years a growing concern around ingredient losses. As consumers call for always more new product on shelves, the plants and the production tools are therefore required to become more agile in changing often the production. During this webinar, we will then focus on the fruit losses in the dairy industry, where PCM have an expertise on. We'll see today that fruit losses reduction can bring a substantial amount of cash and that there are often multiple rooms for improvement. Few tips and tricks. This is a Microsoft Live event, meaning that you cannot talk, but you're very much welcome to raise a question using the Q&A section on the right-hand side of your screen. You're also most welcome to change your anonymous name to the real one so we could see or guess who you are when you raised a question. We'll try our best to answer live, but if we cannot, we'll then individually get back to you with an answer, and we'll also allow you to get in touch with us afterwards. Presenting this webinar today, Thierry Guichard. Thierry is one of our food system specialists. He's been promoting our solutions for years, and he also led the development of a tool to calculate ingredient losses at PCM. Hi Thierry, how are you doing today?
Hi Pierre, I'm fine. I'm fine, thank you. Hi everybody. Glad to have you with us today, and to have to give us the opportunity to share our analysis on this issue that is becoming for more and more dairy companies a major issue to gain competitiveness and avoid to waste too many ingredients. Well, talking about waste, I'm not going to waste your time any longer. Let's start the presentation. That will be split into four different sections. First, we will see, or more than seeing, I will probably remind you where and when ingredients are lost. Then I will ask you a very basic question just to have in mind what we're talking about in terms of amount of potentially ingredients we lose manufacturing yogurts. I'm going to ask you the following question. Do you know how much ingredients you lose every year? Then together we will see how we at PCM, with our technology and expertise, we can help you to limit these ingredient losses. And at the end of this presentation, that will last about 45 minutes, all together we will summarize what are the potential gains we can expect in ingredient losses, implementing the tricks and the expertise we would have seen earlier. Let's go to the first section. Where and when ingredients are lost. Well, first of all, it's very important for you to realize that between 60 and 70% of your ingredient losses while you are producing yogurt are linked to the dosage, the mixing, or the filling stage of your process, between 60 and 70%. The remaining 30 to 40% are linked to all other upstream process operations, such as all the heatings, the coolings, or on the various treatments you apply to your ingredients, and mainly to the white mass, as far as the heating, cooling, and treatments are concerned. So 60 to 70% are coming from the dosage, the mixing, and the filling, the blending, basically. And what I'm talking about here are the losses during what we call an inline process, meaning that the yogurt blending is done inline simultaneously to the filling and packaging. We don't talk here all the figures, all the means to reduce the losses we are going to talk about are not linked to batch process. We are focusing only on the inline process of manufacturing. So if we detail where and when we lose ingredients during the dosage, the mixing and the filling stages, it starts with the starts of productions. Each time you start a new production every day or in the middle of the day, when you start when you decide to start a new production, you will undoubtedly lose some ingredients. During the productions themselves, you are also losing ingredients, mainly due to the dosing repeatability, or more precisely due to the poor accuracy of your dosing. That's the first reason why you lose the ingredient during production. The second one is linked directly to the quality of the fillings, and I will detail those issues in a minute. Start of productions, during container changeovers is also a major reason why you lose potentially some ingredients. When the containers are getting empty, we will see how and why you lose ingredients, but this is a major stage where you lose ingredients. Not only when the containers are getting empty, but when you decide for whatever is the reason why when you decide to change the recipe. When you decide to go from one production to another with new ingredients, that's an opportunity where you're gonna lose ingredients. At the end of the productions, each time you stop a production, a yogurt production, we will see also that you are about to lose ingredients, white mass or fruits or any additives you may have in your recipe. Altogether, what we're talking here related to the dosage, the mixing and the filling stages, we're talking about 6 different sources of losses, First, the losses due to the overdosage, and I'm going to detail that in a minute. Then, in addition to that, we have the losses due to the priming phases when you start the production, the losses due to the container changeovers when they are getting empty, the losses due to any recipe changes you may run in your production, the losses due to the production ends, and the losses due to the filling poor quality. Globally, the poor quality of your filling may lead you, if you have poor quality of filling, may lead you to some losses. Let's detail now the first reason why you lose ingredients, which is the losses due to potential overdosage. Every process where you want to dose, where you want to inject some ingredients, you always have a target which is nothing else than the minimum of ingredients to inject. That's the minimum amount of ingredient you want to inject in your recipe. It clearly means that you are not allowed to go to have less than this target, but eventually you can have more. Not less, that you can eventually have more. Now, like every target, you've got a margin, kind of quality tolerance, in which you will consider that your ingredient quantity will be okay. Let's assume that our margin is here plus or minus 3%, and that to simplify the explanation, we have equal tolerance in plus and in minus. Your injection process is made with an equipment that has its own precision and that will probably fluctuate during the overall process duration. Let's take the assumption here that you use a dosing equipment with plus or minus 5% of accuracy, of precision. Well, with such a precision and fluctuation, you will get variable quantities of ingredients above or below the target. The first category will be the still acceptable product quantity, because it's lower than the target, but higher than the minimum allowed quantity. The second category will be every quantity greater than the target. We are talking here about ingredients extra consumption. Most of the time, these ingredients, either fruits, pulps, or any other additives, being more expensive than the white mass, this extra quantity, if not directly a loss of ingredients, is already a loss of money. The third category of this quantity of ingredient that is below the minimum allowed quantity, this is definitively the kind of dosage you want to avoid, because if it happens, the quality department will reject all production with such quantities, resulting in pure losses. This is why, basically, if you cannot use dosing equipment with better precision, you will need to artificially increase your target to avoid these losses due to underdosage. In our example, you will need to increase by 2% the targeted quantity of ingredients to inject. Doing so, you will be sure of never having underdosage below the minimum allowed quantity. Even if you are in the lowest part of your variations, like I'm showing here, you will never go below the acceptable quantity, never. But, there is a but. In the same time, you have to realize, you have to know that you will increase the quantity of ingredients compared to the original and still contractual commercial target. Well, in short, you are still losing money. We will see in a minute how to minimize this. But you have probably already understood that the key here is to use dosing equipment with the highest possible precision, the best possible precision, to lower as much as possible the fluctuations, and therefore to better control the injected quantities. But we will see how to do that. The second reason why you lose ingredients is during the priming phases. Most of the time, your process requires time on the use of ingredients before getting to these homogeneous mixings. You need to have equipment, including all pipes, as dry as possible when you start your production to avoid what we call the dilution fronts, to avoid them as much as possible. And to have means to obtain homogeneous mixing as soon as possible, especially in case of inline mixing, where every second of flow can see kilos of ingredients going away, if not homogeneous. What about the losses due to the container changeovers when the containers are getting empty? As you know, it is very difficult, well, if not possible at all, to retrieve every bit of ingredients in a container or in a bag or in a pouch. The product viscosity or any suction phenomena may result in ingredients sticking to the edge of a container. A bag or a pouch that is badly handled could collapse and have some parts that will stick each other, isolating the ingredients from the dosing pump and making a poor accuracy in the dosage. Many reasons that will result at the very end to ingredients still kept in their containers and not poured in the yogurt, not sold, thrown away, and definitively lost. In addition to these losses, you have also to deal with the quantity of ingredients that remain in the pipes or flexibles when you manage the changeover of an empty container to a new one. That's another source of potential losses to be considered. When you change your recipe, meaning that you want to replace one production with ingredient 1 with a production with ingredient 2, you're also facing a step during which you can increase your losses. When you stop production with ingredient 1, you probably still have ingredient 1 in your pipes, hopper tanks or other location of your installation. If you don't manage properly, and we will see later how to manage this properly, you will lose this quantity of ingredient and be forced at the end to throw it away before starting your next production with the next ingredient. When you stop your production and the production ends, there are also many reasons why you probably lose ingredients. In fact, the production starts, the recipe changeovers are a source of losses, but production ends are also source of losses. And again, if the production ends are not managed properly, this stage is potentially a source of major losses because of the products, again, remaining in your installation and not going to your cups. I have mentioned the filling poor quality as a major reason of potential ingredient losses. That's true because, in fact, we all have to realize that dosing well, having an homogeneous mixing as soon as possible, and to manage properly all the different transition phases is not enough. You also need to make sure your filling process at the end of your process is well organized. Well, not to spoil all your efforts taken upstream. What I'm talking about here are drops, potential drops, eventual drops or splashes that will prevent you from good cup sealings. I'm also talking about the potential inaccuracy of your final filling that will make cups at the end unacceptable for a quality standpoint.
Well, Thierry, we've seen that there are several reasons to lose ingredients during the manufacturing process if we don't pay attention. So before we have a look at ways to improve things, can you tell us exactly what we are dealing with? What are the quantity of ingredients we are talking about here?
Well, yes, Pierre, that's a good transition to move to the next section of this presentation. And I told you that I will ask you a basic question. Do you know how much ingredients you lose every year? Well, you cannot answer, but you are probably having some figures in mind. If not, what do you think? Do you think we are talking about for each individual packaging line you may have in a factory? Do you think we are talking about 1 ton per year? Do you think we are talking about 10 tons a year, 100 tons a year, 300, 500, 600, 700 tons a year, more? What do you think can be potential losses if you do absolutely nothing to pay attention to this issue? Well, our experience shows that it can be up to 700 tons per year. I'm talking here about losses of white mass on fruits. That's typically what you can unfortunately lose if you are running a highly productive multi-flavor packaging line, meaning, for example, 5 productions every day, each with 4 flavors per day, at the speed of 28,800 cups per hour, and running these 20 hours a day. Highly productive packaging line. Yes, the losses can be up to 700 tons a year. Well, it can be seen probably as enormous and totally crazy. But first, I just want to remind you that this is only between 3 to 3.5% of the total consumptions of your ingredients, 700 tons. Those figures have been reported to us, or very similar figures have been reported to us by several dairy companies in the world. So that's something that can be challenged. And as we have briefly seen together, this is the addition of multiple sources of losses. So the 700 tons a year are all the addition of the different sources we went through a while ago. Up to 700 tons a year for highly productive packaging line. Well, this is probably not everybody that runs such a highly productive production. But even for smaller companies with smaller productions, the loss quantities are still potentially very high if one does not take any particular action. It can be up to 50 tons a year for small production, meaning one production with one single flavor per day at the speed of 10,800 cups per hour, and just running this production 10 hours a day. So 50 tons per year for small productions. If we look more in details where those losses potentially come from, the 700 tons a year for highly productive packaging line are split between 20 tons due to the poor quality of the filling, 20 other tons due to the potential overdosage, 360 tons related to the different transition phases, the starts, the changeovers, the ends. 360 tons can be easily lost if you don't pay attention to those transition phases. And the remaining 300 tons are linked to the upstream processes outside of the dosage, mixing and filling. For the 50 tons, it is split between 3 tons coming from linked to the poor quality of the filling, 3 tons due to the overdosage, 30 tons to the transition phases, and the remaining 14 tons coming from the upstream process like heating and cooling. Well, I'm not going to detail here today. Up to 700 tons a year or up to 50 tons a year for smaller production. Well, again, it may seem as enormous, but it's a reality. And I have a bad news also, news that is not good. It's that it can be worse. It will probably increase, those figures will probably increase or could increase because of the trend we can see today for more flexibility with more recipes, more productions per day on smaller batches. So those figures, if we don't take them seriously, can be even worse.
Okay, Thierry, so hopefully no one is losing all these quantities of the ingredients because most food industry have already started to tackle this issue, but shall we see now what can be done and what are the solutions to minimize the losses?
Yes, Pierre. Now what I propose is that we go through the means we at PCM have identified to optimize, to minimize those losses. We have identified no less than 10 different means to minimize those losses. Let's go through those means, those 10 different means. Starting by mean number 1, which is nothing else than just making sure that when you start a new production, there is no more water or no more water condensation in your pipes on your equipment. So it means that you have better to make sure you have purge valves at the lowest points of your installation, and that eventually you can use air drying to completely dry to dry your complete installation. So mean number 1 is nothing more clever than that. Just be able to purge and dry all your pipes to avoid water remaining in your installation and to ease the homogenization of your yogurt as quick as possible. The mean number 2, and here we start to talk about all the means that will improve the transition phase and that will allow basically to anticipate and to optimize the production changes on the production ends. Here we are talking about the ingredient changeover with ingredient to ingredient push. What does it mean? Let me show you, let me explain you this more in detail. That's a basic scheme of what could be an inline installation to produce yogurt. This is in here the dosing pump you use. The fruit contained in 2 containers that can be linked to your dosing pump. You've got the white mass coming this way from a pump and through a hopper tank. Here we've got the injection point where we will inject the fruit to the white mass. The 2 will go to the inline mixer. and at the end it will go to the fillers to be poured in the cups. Well, imagine you are running the production with the first container, the container 1, full of fruit A. So you run the production. In the same time, while you are running the production with this fruit A, what you can do with our equipment is to using the fruit, another flavor contained in another container, you can prime this container, basically have it ready as soon as possible. It simply means that you will prime all this flexible, you will make sure you will have it full of fruits to speed up the changeover process. So this can be done in the same time of the production while you are producing with the fruit A without stopping the production. When the container 1 with the fruit A is getting empty, or when you decide to change your recipe to move to fruit B, what happens is that you will, with the different valves we have installed, without shutting down the production, you will use the fruit B to push the fruit A, which was still trapped, still contained in the pipes, to push it until the cups. Doing that, you can retrieve all the quantity of fruits and white mass and yogurt contained in all these pipes that can be 10 meters long. And again, this can be done without stopping the production, just because you have the possibility to prime this small part of your installation with the fruit B. Okay, obviously, when you do a fruit-to-fruit push, you've got what we call a dilution front, which is a mix of the two fruits you have to get rid of. This is why you need a specific valves system to get rid of this dilution front, not to have the mixture poured in the yogurts, poured in the cups. Well, if I'm showing you how it looks like on a 3D animation, that's a typical PCM fruit station. So while you are producing, you can prime with the second fruit, the fruit 2, from the container to the dosing pump, while you are producing with the first fruit in red here. So you never stop the production. When you decide to change from fruit 1 to fruit 2, you just change the valves, and you have here what we call the dilution front, but you can still retrieve a large amount of fruit 1, pushing it by fruit 2 and allowing you not to throw it away. So that's ingredient to ingredient push. For some configurations, not all of them, but for some specific configurations, sometimes it's better to run what we call water to fruit push. Instead of fruit to fruit push, you can run water to fruit push that can allow some lower ingredient losses in some situations. So we are talking here about the mean number 3, which is intermediate water push. Again, if I show you again the same scheme, what it is about is just the possibility, instead of pushing with a second fruit, we are talking here about the possibility to push with water that will come from the pump inlet. And doing that, using the water, you will push the fruit still contained in the pipes downstream the pump until the filler heads. So it's water to fruit push. If I'm showing you in a 3D animation, so you can have the water coming down to your pump, which is here. You will use this water to push the fruit still contained in the pipes, allowing you to use all this amount of fruit contained in the pipes to finish the production. There is also another possibility, which is even smarter than what we have just seen, which is the possibility to push those fruits, those remaining fruits, directly from the container foot. Let me show you again using the same scheme. You see, this is just this possibility. Instead of sending the water to the pump, to the dosing pump, you send the water directly to the container fruit that will allow you to retrieve all the fruits contained in those flexible houses between the container and the dosing pump. So it's an extra saving that can be made possible. The mean number five is the possibility to rinse and sterilize your installation, just focusing on the container fit only. Let me show you. That's a basic P and ID of a standard fruit dosing station, where you've got the pump, the dosing pump here, you've got the container on the top. In between, you have several possibilities to allow access of steam, to allow access of CIP, of water, and so on. Well, if we do a zoom to this to this container fit area, what I'm talking about here is those specific connectors here that will allow the water arrival between the container foot and the beginning of the flexible houses. It means that the water will go this way, and you will rinse only the small portion of the flexible, meaning that you can isolate all these flexible houses section in which you still have some fruits. You will close this manual valve, you will keep the fruits inside the flexible houses, and it means that when you will replace the container, you will move to another one, a full one, obviously. Then you will be able to run a steam sterilization of this small portion only between the container foot and the flexible, which has been the only part in contact with air. And obviously, this is the only part that requests steam sterilization. So doing that, you can retrieve all the quantity of fruit still kept in the flexible houses without losing them.
Thank you, Thierry. So all this means aim at finding ways to limit losses during the various transition phase of a yogurt production, right? So if I got it right, tricky transition phase are the start, the change of containers or ingredients, and the end of production. And we know that they can be various depending on the complexity of your organization. Could you now tell us more about quantities?
Well, yes. In fact, if we take into consideration only those 5 first means, if you do nothing special regarding those transition phase, change of fruits, change of container, if you do nothing, then for a highly productive production, you take the risk of losing not less than 85 tons of ingredients every year. Production after production, start after start, container changeover after changeover, recipe change after recipe change. If you don't use one of the 5 means we just went through together, you will probably lose not less than 85 tons. On the other hand, if you apply all of those 5 means, you will reduce those losses by between 7.5 tons to 13 tons a year, meaning a gain of 15% of fruits every year. That's for the highly productive productions. The figures are probably less impressive for the smaller production. 12 tons if you do nothing are probably the loss you will suffer from. That can be reduced to 2 to 3.5 tons a year, a gain of 30% of fruits if you implement the 5 first means we just saw together. The mean number 6. Now I wanted to describe you the benefits of using a dosing pump with no dead volume. A pump with no dead volume, what does it mean? It means like the pump we are using to dose fruits. It means this is a pump that when it stops, there is no ingredient kept in its body. When the pump stops, each time you stop at the end of the production, for example, you are sure that you will not have product, fruits kept in the body. This is what it is about. No dead volume. Now, what does it bring in terms of minimization of losses? If you use a dosing pump with a body of 1 liter, only 1 liter of body for a standard dosing pump, that is classical for a standard volumetric pump, then altogether, primings after priming, ends of production after ends of production, this is not less than 17 tons of ingredients of fruits you will lose every year, not less than 17 tons for highly productive packaging line. With a doses pump, with a PCM dosing pump, with no dead volume, you will reduce those losses to 0. No losses due to product remaining in the pump when you stop your production. So it's very interesting. Instead of 17 tons, you will lose only 1 ton if you run small production, single production a day. But again, you will retrieve absolutely 100% of those potential losses if you use a 0 dead volume pump like the doses pump. The min number 7 is the optimization of the containers emptying. If you use pressurized containers, you need, if you want to optimize to minimize the losses, you need to be able to detect and to exhaust the potential air bubbles trapped in the container in order to avoid what we call the false detection of container emptiness. You may think, or your system may think your container are empty because of single air bubbles, and you may decide to throw it away, replaced by an empty one, by a new one. But in fact, it was not. The first one was not completely empty. It was a mistake, and you are about to lose all the remaining fruits inside this container because your system is not able to detect these air bubbles. You need to have a system to detect these potential air bubbles. Maybe to improve that, if you have a system that will let the container decant when detected as empty, you know when a container is empty, it's never completely empty. You still have some fruits depending on its viscosity. You still have some fruits on its edges. And if you have a system that will allow decantation, meaning being able to go back and forth from one container to the other, when it's detected empty, you switch automatically without stopping the production to a new container, and a while after you come back to the first container to retrieve all the fruits that has decant at the bottom of the container. So it's something that has to be considered. Well, another good advice, obviously, is to minimize the length of the flexible houses between the containers and the dosing station. The must being to have the possibility to load the containers on top of your station. In case of bag-in-box, the same advice is to minimize the length of flexible between the bags and the dosing unit. And you can also think about having a system to avoid the bag to shrink on itself, to shrink on the bags to shrink on themselves, creating isolated pouches of fruits, making the suction difficult or impossible. That's something to be considered if you really want to optimize the suction of your bags. Here, and in terms of values, what we are talking about is nothing less than 12 tons if you do nothing special regarding the optimization, the detection of the air bubbles, or the optimization of your bags handling. You can potentially lose 12 tons. You can reduce between 6 to 10 tons if you apply the means we just went through. 2 tons only for the smaller production are the potential losses. They can be reduced to 1 to 1.5 tons a year if you use the appropriate equipment. Min number 8 is to be able to use a high-level equipment, high-level dosing accuracy equipment. Or dosing equipment has an accuracy of plus or minus 0.5%. That's we call the repeatability, 0.5%. And this is a figure, whatever the dose and whatever the speed of your the rate, the flow rate of your production. It's always plus or minus 0.5 repeatability. What does it mean? You remember the curves we saw a few minutes ago, showing us what can be ingredient losses due to poor accuracy of the dosing. You remember those curves. If you replace poor quality equipment by highly accurate one, let's say 0.5% of repeatability, like PCM ones, this is what you get: a much flatter curve. And compare to the original target, you still have ingredient extra consumption, but much lower. And in the same time, it's also very important to notice that you never go below this target, because we need to remember that we have artificially increased this target to avoid non-acceptable products. Remember. With better repeatability, we can now lower our target, resulting in less ingredient consumptions, but still within the range of acceptable quality. You can even lower this target to a level in which you will always stay below the original target and will never go below the lower acceptable limit. If you do so, and thanks to the high level of repeatability of the dosing equipment, you have no longer yogurt with too much ingredient in it, and no yogurt with not enough ingredient. Basically, that's a kind of jackpot. And here, potentially, the gains are quite incredible. If you use a poor quality equipment in terms of accuracy, well, let's take the example of if you use an equipment with 1% accuracy, which is not too bad, but it's not that good, because if you use an equipment with 1% accuracy, I'm sorry to let you know that you take the risk of losing as much as 18 tons a year because of this 1% repeatability. If you use 0.5% repeatability equipment, it can be reduced by 2 or completely retrieved if you take the risk of lowering at its maximum the target. 18 tons for a highly productive production, 3.5 tons that can be retrieved just using highly accurate dosing equipment. The mean number 9 is what we call the just-in-time dosing and injection. What I'm showing you here is a classical, what we call inline injection process. The additive, let's say the fruits here or anything else, is dosed and injected to the white mass here through the injection point, proportionally to the flow rate of the white mass. And to do that, most of the time, we need to use a flow meter on the white mass and set the pump, the pump cadency, the pump speed to this flow meter. So we need a flow meter, and you also need a balance tank, a hopper tank, after the mixing, after the mixers, to fill it for the filling unit, for the filling station to use for filling. Well, that's classical inline process. In case of multi-flavors, if you use 2 different flavors, well, you have to multiply the number of flow meters, and you have to multiply the number of hoppers, potentially full of yogurt before they're filling. Now, with the PCM technology, you can set up a process we have called just-in-time, in which you have no longer flow meters to manage the proportionality, no buffer tanks full of mixed yogurt. So this is what we have called the just-in-time mode, where the dosing of the ingredients here is synchronized to the speed of the filling machine, and no longer to the flow of the white mass. One stroke of filling, give one given quantity of ingredients managed by the dosage pump. So no more hopper tank full of yogurt, no more flow meters to control, to buy, to maintain, and to clean, and to worry about. No more. With that, and it's also a very impressive result you can gain, you can reduce drastically, you can save between 26 to 52 tons a year, depending on your configuration, basically depending on the size of your intermediate hopper tank you have in the inline. You don't have any longer in the just-in-time mode. So you can reduce by 26 to 52 tons a year those potential losses. For smaller production, we're talking here about a gain of 10 tons a year, which is very interesting. The last mean is related to the mixing itself, to the inline mixing. We strongly recommend you to make sure that the piping of the inline dynamic mixer is optimized. It means that all pipes between the mixer outlet and the fillers should be as short as possible and with equal length and equal pressure drops. That's a very basic advice, but we strongly recommend you to follow this advice. And we also strongly recommend you to have the fruit injection point as close as possible to the mixer inlet. Make sure you will start the filling. You will start filling the inline dynamic mixer only when rinsed and drained. No water in your dynamic mixer to speed up the homogenization. And make sure that to use all the mixed product contained in the inline dynamic mixer at the time you decide to stop your production. Find a way or another to use all the fruit, all the yogurt contained in the dynamic mixer. So to do that, we can provide you with the proper equipment, the dynamic mixer, with specific equipment to manage the mixer filling, the emptying, the mixing homogenization. We can help you in well designing the mixer outlets between the mixer and the fillers. So that's basically, that's basically the kind of equipment we can provide you with the necessary sensors to control if when the mixer is empty, when it is full, and to take full benefits of this management. Well, it looks very basic, but this is probably here that the most amazing gains can be expected. If you do nothing, if you don't manage properly this mixing, well, you will lose a bunch of ingredients. 225 tons a year is probably the amount of ingredients you will lose if you don't do nothing special regarding the management of the dynamic mixer. So it can be reduced by 185 tons a year if you do it properly with the proper equipment and the proper processes. For the smaller production, you take the risk of losing 12 tons a year if you don't do nothing in particular.
This is very interesting, Thierry. So shall I summarize here? We've said that the optimization of the mixing stage, and more precisely the different transition phases, seems to be a very important stage to save ingredients. Major gain can be expected from this step. Running in just-in-time mode, synchronizing your dosing units to your filling station is also a very efficient way to minimize losses. And we shall not forget to deploy metering equipment with the highest possible precision. Well, I think it's time now to wrap up this presentation, but could you summarize for us what are finally the gain we can expect from all these advices?
Yes, yes, Pierre, it's time to wrap up. And just very quickly, I just want to summarize the quantity of ingredients, both white mass and fruits You can save if you manage properly all the phases or the processes we have seen together. Let's start with the highly productive for fruits production, very highly productive production. Remember, I told you that if you do nothing, you take the risk of losing not less than 700 tons a year. Those 700 tons a year were split between 568 tons of white mass and 132 tons of fruits. So this is the split if you do nothing. So with all the means we just went through together, you can expect major saving. You can decrease the white mass losses by 37%. And more impressive than that, you can decrease your losses related to the fruits by 65%, coming down to 86 tons per year of losses instead of 132 tons of losses. So it's a major gain just using the right equipment and the right processes. Well, for the smaller single fruit production, I told you that you may lose 50 tons a year, 37 tons of white mass plus 13 tons of fruits if you do nothing special. Well, if you apply all the means and the expertise we have just seen, it can be reduced by almost 50% for the white mass and almost by 90% for the fruit losses. So you can have only 1 point. You can expect to have as low as 1.5 ton of losses as far as the fruits are concerned if you manage them properly.
What impressive numbers. Thank you very much, Thierry, for all these inputs. We certainly hope that this will open up new rooms for ingredient savings in your business. And we'd like to thank the audience for your attention today. You were over 60 people attending this webinar. We will come back as soon as possible to those who have raised questions. For further discussion, feel free to contact us on the email address which were in the invitation, or you can also note it from the slide right here. In those challenging times, as a conclusion, I would say that it's extremely difficult to predict the market demand. So the profitability can hardly rely on the business growth only. However, savings on costly ingredient losses are often a quite low-hanging fruit. Some adjustment or equipment upgrade can bring substantial and immediate amount of cash. So could be different ways to do it, but bear in mind that it's also very green to chase up food wastes. So whether you want to be green or more profitable, we'll be happy to be by your side. Thank you. Have a nice day. Bye-bye.
Thank you, everybody. Bye-bye.